Let's pretend you are still thinking what programming language you want to learn and you don't know it yet. What would you do? Well, you have to ask yourself what's the point, what's the purpose, whether it is data analysis or you want some websites or make some apps for your mobile phone, or I don't know, rob the bank. No. Depending on your choices, then you have to start looking around what's the best tool, what's the best language. In every language it matters the grammar, the readability, whether it goes into your head easily or not, what are the packages provided, and so on, and how big is the community whom you can ask questions. And in this respect, it is useful to check this PyPol popularity page, which makes me thinking that it's probably biased on Python, and Python is always number one, almost always. Very likely it is true. And then R is number 7, which is not bad at all for R, because it is not universal, unlike to Python. It's very specific. It has a much smaller community. But if you are in biology, your choices are very limited, because you will need biology-related packages for your data and applications. You cannot survive without them. And the list of languages which have biology-related packages is short. It's only 7, to my knowledge. Maybe there are more, maybe. There is a new language arrived recently, Julia. It's a very unfortunate name, because if you Google it, then you get lots of other Julias next to the language. The ambition is that it is faster, more powerful, more flexible, and the readability is as good as in Python, and it can integrate other programming languages in it. But probably for an experienced user, it is a bit too early. So what about R? R is first the name is a bit funny. It came after the monumental effort of creating language called S, which is still running at the back of SPSS commercial package. And R, it was some splinter group from New Zealand who decided, well, we will make something smaller but useful, at least for us. And since 2000 it went public. It is exactly the tool for statistical data analysis, and it has a bioinformatics department, and it has beautiful illustrations. They are created within RStudio, actually not by R itself, but by RStudio, but RStudio is also supported by the same community. And if you are in a gene expression, I will talk about gene expression, then there is no choice basically, it's only R. So only R can do analysis of expression microarrays, bulk RNA-seq and single-cell RNA-seq. A small part can be done in Python, mostly single-cell RNA-seq. You have to install R and RStudio. You can find both in RStudio webpage, which is a post-it, don't be confused. There are other editors in addition to RStudio, but it's more for enthusiasts of looking for a trouble or making or trying something more complicated than others. I would not recommend any of those. you will be instructed if you go to buy conductor, for instance. For every package you find, there will be instruction how to install it and tutorial supplied. If you are in Mac, then you will have to install Xcode and Xquartz. In Linux, there is an analog of X11. You can Google it and find it. You will also need. In Windows, no extra installations required. That's about it.